Hi everyone, welcome and thank you so much for a very warm introduction. I'm really happy to be here today talking about AI agent testing. Let me briefly introduce myself. I'm an engineer and co-founder at Evidently AI, where we build tools to validate, monitor, and test AI systems. And yeah, I need to mention that we do have huge open source library with a lot of metrics and tests to help you validate your LLM and not only LLM-based applications. And well, we do have a lot of GitHub stars, a lot of downloads, so there are a lot of teams coming to us talking about deployment and CI/CD for LLM-based applications. Also, I need to mention that I very agree with what was said before about domain expertise, and that it's very important to bring some domain experts to help with drafting these workflows and tests. So we also have UI no-code platform where everyone can draft tests for your LLM-based applications as well. So yeah, I'm very excited to talk about agents testing because it's so cool when we can meet best practices from engineering, how do we do CI/CD, and how we do test our software together with some data science and bring up all these things together. Well, just to make sure we are on the same page about what is AI agentic systems, I need to say that by agentic system, I mean the tool which has some memory and state. It might also have some access to tools like maybe reg system or web search or file search or maybe some computer use, whatever you can use as a tool, right? And this system has some planning and routing abilities so that it can iterate over and over to make sure it gives you the best response. So this is something which you can imagine as an event loop with the planning abilities. That's AI agentic system. Well, what makes AI agentic systems testing hard? Actually, a lot of things. First of all, we never use agents for simple workflows because it's cost, it's kind of not fast, let me put it like this, and it does take a lot of effort to bring it up all together. So it's not like you create an agentic system to write you a summary of an article or to create you a nice tweet, right? It's rather when you have a lot of users, maybe querying different things about orders or products or seeking for help or something. So there are quite a lot of databases involved, quite a lot of tools, so it's really complex. This is why even building an AI system is quite complex, and if you need to come up with the testing, it's also a huge part, right? I also just mentioned event loops, so there are a lot of things going on, and just imagine if you have an error or issue occurred at the very beginning or at the very middle. It is hard to detect it itself, like that output is not well, right? But we need to also figure out when exactly and where the issue has occurred so that we have chances to debug it and solve it, right? So that's pretty complex. And also, of course, it's free-form output. Unfortunately, it's not like what we had for classification or regression, where we can easily just say, hey, here is my output, here is a label, here is the ground truth, and I can just compare it. It's a free form, it can be multimodal like video or picture and text together, and it doesn't make sense to create our testing on pixel-to-pixel comparison bias, right? Or maybe word-to-word, it just doesn't work like that, so we need to be pretty creative on our testing. So yeah, I think that's pretty challenging and very interesting. And well, how do we solve it? Basically, there are two parts to the solution. First is software engineering, so we need to take best practices from our software engineering experience and somehow fit it into our non-deterministic systems, being more analytical. And by being more analytical, I mean that, well, when we do test robust systems, we kind of assume that if we test our function once, like a function which, for instance, sort the list, then, well, if it works, right? But when it comes to non-deterministic systems, you cannot just say, well, let's test the output of my LLM once, and if it's correct, it's correct. It's not like that, so we need to do a lot of experiments, create a data set, and then calculate some statistics like 9 times out of 10 it works. So we need to combine both this approach all together. And well, I guess it will be good if you just start from the quick recap on software testing, and I promise it's not going to be long, like 3 minutes, not more. Just to make sure that we'll remember that when it comes to traditional software engineering, we do have a huge hierarchy with a lot of different testing, right? And we always start from unit tests because it's fast, it's cheap, it's easy to implement, kind of. We need to cover all our code repository with this unit test so that everything is tested. And then we kind of go through component testing to integration testing, then end-to-end, and finally, we have our CI/CD covered. After, we can do some regression testing to make sure that our new changes do not break something we built before. Then, of course, security, especially if users are involved. Performance testing for pretty huge systems. User acceptance, and finally, we do production monitoring so that we have a dashboard, better live dashboard with a lot of alerts so that we understand if something has happened immediately, right? So that's the ultimate goal. Of course, that's huge, that's a lot, and no one can implement that like in a day, right? This is why I suggest us to be really pragmatic, especially when it comes to complex systems, and start from CI/CD. And when it comes to CI/CD, I mean continuous integration and continuous testing. That's really important, because when it comes to agentic systems, we do really iterate on our prompts, on our tools, on the combination of all this together. So it's super important to make sure that on every single step of your improvement, you can cover it by your tests, and you know at least that you are not breaking things down, right? So you are really improving. This is why I suggest us to focus on unit tests, integration tests, and end-to-end tests for our agentic systems. And yeah, so the logic behind those tests are pretty straightforward, I would say. Unit tests is the base layer, so we always prioritize that. We start from unit tests, and the idea here is very narrow. We treat every part of our system as unique evaluation blocks. Let's say functions or class methods from the standard development, right? And the idea is that we can write pretty narrow tests that just compares the output with our expected outputs, and by doing that, helps us to catch like 90% of bugs. They're all there. But when the complexity of our system grows, we need to make sure that individual components work fine together, that they are connected nicely, right? My favorite pair for now is like retrieval and generative part of reg systems. Even if you have great retrieval and great generative part, you need to make sure it works fine together. This is why we do need integration tests. So the idea here is to ensure that combined units cooperate nicely and correctly. It's a bit like slower, so we cannot test 100% of our systems, but it does make sense to implement at least the testing for a lot of components which tends to work together. And finally, we have the end-to-end test. It's the top layer. It's the closest to what your users see, actually, and that's like a whole workflow. It's not necessarily should be in a UI, like user comes, log into your system, and do everything, for instance, for post generation or article summary creation, but it can be also a command line. So if you do have some workflows, you can just trigger it from the very beginning and see whether it worked or not successfully. So that's kind of the idea. There are some drawbacks here, because that's the slowest, and I would say the most expensive. If there are some large language models involved, there would be a lot of tokens, right? So we cannot really have a lot of such things. But it's important to cover at least the main user flows, maybe with some edge cases, so that you understand, at least at the pre-deployment phase, that it works. So that's our groups: unit tests, integration, and end-to-ends. And of course, there are quite a lot of best practices which we can apply to AI agentic testing. First is that we do prioritize unit tests. That's super important, right? We try to cover all our units and functions by unit tests. Then we can be more like strategic regarding our integration tests. That's important to cover by integration tests all critical components, but it cannot be like everything. Then we move to our end-to-end test, and here we need to cover for very essential user flows and maybe a couple of edge cases if you know that it happens and they need to be covered. And then, like a cherry on the pie, is if you can automate this. I think when it comes to unit tests, even in agentic world, you can use it even in pre-commit phase. When your developer is doing some improvements or bug fixing, you can do that. It's even better if you can automate everything, including integration tests and end-to-end tests, have it implemented in your CI/CD and pre-deployment tests. It's really helped make things better. But it's also important to understand that while our product is growing, we try to introduce more and more features, right? We try to make it more complex. We try to, of course, catch and fix all bugs. So the features became more interesting, more complicated, and same should happen with our test suites. So we cannot just implement new features. We need to adapt our testing procedure so that we also cover for new features and more complex workflows. So it's like a never-ending cycles. You implement new features, you update your tests, and that's how it works, unfortunately. That's what we also like to call tech debt, right? Nobody wants to allocate time for creating tests, but everybody's happy to write more features. But we are trying to keep it balanced, right? That's the idea. So now the question, how do I apply it to AI agents? I think that's the very interesting point, and later I'm going to introduce to you an ideas of what tests you can implement as the unit tests, integration tests, and end-to-end tests for agentic systems. And I do hope that it will be interesting and we can discuss it later as well. So as promised, best practice is to cover everything by the unit tests, so we start from unit tests. When it comes to agentic systems, there are a lot of building blocks we use. But generally, we do a lot of prompting, right? Because that's kind of how to instruct our agents to what we expect it to do. Also, we might, and generally we do have a lot of tools. It can be some robust tools like access database to some query and derive some information. It can be web search, or it can be some LLM as a tool things, like maybe the other agents, or maybe reg systems, or maybe some completion systems, right? So those tools can be also non-deterministic. So the idea of unit tests is that we can treat every single prompt and every single tool as an evaluation block, like just a function, which gets some input and returns some output. So we can check the quality of those things by checking input and output and formatting. And let me bring some examples here. So prompt validation. I believe that's very important because it's not like that's straightforward, especially if we write this prompt ourselves, like we wrote it, we like it, that's it. But unfortunately, it's not that good for LLMs. And I think we can just kind of try and imagine ourselves being this agent who tries to solve the task in the best possible way. In this case, we need to make sure that we have all needed instructions, like system prompts, system instructions are here, some relevant context should be here as well, some user inputs, and it's better if we can distinguish one from another, right, to be able to finish the task in the best possible way. So that's what we can test in our prompts. And it's especially important if you do it automatically. Like, remember those wonderful Jinja templates when you try to like compose this long prompt and it doesn't work. So yeah, this is why prompt construction is also very important. You can do it with help of simple checks, like just after we completed the prompt, let's check whether a task description is here. Let's check whether we do have our context, etc., etc. That actually sounds pretty easy, but it makes sense to do that. Also, there is thing with input formatting and output formatting, and that's also important because, well, there can be a lot of tools which expect particular output from the previous step, like correct JSON, and it's not just the correct JSON. Maybe we expect that in this JSON should be presented name and age with certain types. That's important. And this is actually something which we do it. Evidently, we help to write those tests faster. 100% you can implement it with help of PyTest, but if you prefer to make it faster, here are checks like JSON scheme match. I really like it because you can mention all needed fields like name and age and say, well, it's not exact match, so we allow our JSON to have some extra fields, but validate types is true. So we check that age is integer and name is string. So that's kind of things you can do, and it's really helpful because it helps to catch a lot of bugs. Well, that's prompt validation. Let's say we have all our prompts covered, hopefully, and we can move on to our tools. In this case, we can explore different approaches to work with the tool. First is like, I get my tools as the ready-made components, so I'm not kind of trying to test its quality, I rather test the input-output. That's the first approach when, for instance, I'm responsible for my agentic system, someone else is responsible for RAG, which is shared across the company. So in this case, I'm not trying to really validate the RAG quality, I'm just trying to check whether my agent can work with this RAG system. In this case, I can also focus on some execution success, maybe failure handling and input-output. And my checks could be rather simple. Here, just to entertain you a little bit, is an example of functions which can be covered by PyTest later. So basically, the function asserts true or false, whether our test has passed or not. In this case, it's just gross calculation, so we have previous value, current value, and the result should be like the difference between them. That's how we can do it with help of PyTest. Sounds good? Very nice. But actually, when it comes to using LLM as a tools, do we really use it as a ready-made? I cannot say so, because very often, if your agents need a RAG system, you're the one who builds it, actually, right? So in this case, we need to implement more complex tests to make sure that something we built as a tool actually works exactly as we expected. So again, you can bring up here all the previous checks for input-output formats. It's important and it works as well, but quite often, when it comes to using LLM as a tools, we have quite a lot of expectations regarding the answers quality and other things related to maybe jailbreaking, security, and other stuff. How do we approach that? I believe that's quite interesting because when it comes to LLM quality estimation, I believe there are two main directions we can take. First, we can do it with help of our ground truth. Second, just direct scoring. And I'm going to talk a little bit about both options. When it comes to checking the quality of our LLM-based applications, and here I generalize heavily. I mean agents, I mean reg systems, I mean just simple completion, one shot, everything works here. So in this case, if we do have a chance to generate for ourselves ground truth, which is not like ground truth in classification or regression, more like the reference output, which is known good, but you might have different versions of nice data. So in this case, you can build up your quality testing system by comparison. So like you say, here is my reference answer, here is what my output is, and I can calculate something like maybe semantic similarity or other way to compare similarity between the text data. Other is direct scoring, and we'll talk about it a bit later because I want to start from the example. So when it comes to ground truth, it might be something like this. You have your system, and you say like, here is my example queries, and here is non-deterministic system. So it should be a data set, not just a single query, right? That's important. At least start from 10. It's already will be nice. So here is the example queries. And here is the ground truth answer. So this previous year, December 24, was not bank holiday, I hope. So then you can ask your LLM generate the output, and you just compare. If it says, unfortunately, no, just no, or of course no, it's all semantically close, so we can say it's correct. Right? That's basically the idea. And of course, you can build quite a lot of such things, and I do really recommend to build it, because if your agent cannot rely on the tool it uses, that's a drama. I would say this is disaster. This is why we do really need to implement a lot of such kind of checks. But when it comes to correctness, and when we have some ground truth, I think it's more or less covered because it's very similar to what we do with traditional machine learning. Let me just quickly bring the following example. Let's say that you have a chatbot, customer-facing, which is supposed to help your customers with the product, like answer some question, help something, or maybe just figure out what is the order status. And then customer says, yes, actually it was very helpful, but how do I flatten a list in Python? Well, it's not like security violation. It's not related to bomb or something. It's like normal question. And you say, well, I'm LLM, I know, so well, why not help you? But unfortunately, it's not something we want to spend our money on, right? Well, it's not very nice. And this is something which can be also covered by a test. How so? We can do something like answer safety. For instance, we can say that we don't want our LLM chatbot to be involved in off-topic conversations. Just if it's not related to our product, do not engage in this conversation. And same approach works with forbidden topics or maybe jailbreaks, where the user tries to derive some information about the system prompts or some other system internal details. How do we do that? Of course, the approach with the ground truth doesn't work here because, well, it's not related to the quality, but we can do direct scoring. LLM as a judge is a very nice approach here because we can formulate as a criteria of what is the off-topic conversation and what is targeted conversation, or maybe what is safe or what is unsafe. To do that, we can have our separate prompt, which have this criteria and doing kind of a labeling for us. And then we can see the reasons and see why actually for every single question we decided to say it's safe or unsafe. And that's more or less how it can look like. Again, this is an example from Evidently where we do have this LLM evaluation, and here you can create your own criteria. Like the response is safe when, and then I just did not proceed with that because I never do it myself. LLMs help with that, of course. And then you say the response is unsafe when, and again, you can ask LLM to help you to continue this description so that you create your own criteria. And then you can say, now I have my LLM judge. I can apply it to my queries and see some statistics about safe and unsafe queries. Then, after you have it, you can kind of update the instructions and prompt from your main agents. Why so? Because you have some feedback and you understand what you need to say. Maybe say never help with flattening Python lists, or maybe something more general. Yeah. That's what we can do on top of our individual units. So prompts, LLM input-output, and the quality of your tools. Now move on, because we also do have some integration tests. Here the idea is that we're trying to figure out how good our components work together as the team, let's say, right, or as a chain. So here we can test quite a lot of things, but I'm going to focus only to agent-specific. When we do use a lot of LLM systems, there's always a lot of dependencies and issues with environment and configuration, some secrets, etc. So this thing should be tested. Also, tools and API integrations. I believe nobody likes a lot of external API because you have no control over them, but you need to make sure that you can use it, right? Also, some things related to memory and state propagation, planning and routing, and multi-agent cooperation. I will try to briefly cover all of them one by one so that we understand where we can use our integration testing approach. Starting from environment and configuration tests. It's not that complicated, but I just want to explicitly say that it should be done. Just imagine that in your production system, you miss a couple of secrets. For instance, for a couple of LLM providers or anything else. That's a disaster. I mean, it's always like funny when in your testing environment or locally everything works, but as soon as you deploy it to some external servers, unfortunately, something is happening. This is why it's very nice to have a couple of tests where you, for instance, monkey patch your environment, delete a couple of variables, and see what's happening if you don't have it. So that's kind of important part, especially when we have a lot of secrets and external APIs. Then move on to tools and API integration. Here again, we do have a lot of databases, external APIs, and well, that's important to make sure that your engine has an access to those databases, especially if it's like a tool which is supposed to help with retrieving some information about orders or customers or users or products. What's not, it's important to make sure that from the environment your agent uses, you have this access to this database. And same goes for API reachability. Also, quite often we do have some issues with timeout or maybe failure because it's all non-deterministic systems, right? So it's also important to check whether your tool is able to gracefully handle situations where, for instance, you have a timeout issues. It's not just break the entire event loop, but return something like, let's try again, or unfortunately, I wasn't able to drive this information, or something like this. That's important. And well, actually, there is one more thing related to authentication and headers, and it's very specific for agentic usage. Why so? Just imagine that from very beginning you manage your memory and you do have all needed information presented. Like you have all tokens, you can build up all headers using needed tokens, and you can easily query any, let's say, external LLM. But after you started your event loop, you had several steps, so those steps also interacted with your memory, so they added more and more context. Some context can be removed just because you have it limited. And at the moment when you need to query your third-party API, unfortunately, you already do not have these keys and in your headers, and you cannot do that. This is quite an issue, right? And this is why such things can be and need to be covered by tests. Like, are you able to call your API from the very first step of your agentic function? What if you call the same API on the 5th step? What of the 10th? That's important. So that's what we can also test. Speaking about memory, that's actually a big topic here, because we started from the fact that our agentic function, our agentic tool should have memory, right? And the way how we communicate and manage this memory cannot be underestimated. I mean, first of all, we need to make sure that our memory initialization is correct. That's really important, because if you miss something in your memory from the very beginning, the workflow, the length of your workflow can be like twice longer than it might be if you loaded everything you had in the very beginning, right? And that's cost, that's time, right? We really want our workflow to be as brief as possible. Then we go to memory updates. When we do some steps, it's very important to make sure that all needed, let's say, traces from the current step are added to the memory. That's important so that you do not need to call the same tools again and again later on your later steps. It can save quite a lot of steps and quite a lot of tokens, so I think the recall fidelity is something that needed to be tested. And also something related to session-specific memory, right? It's important to be able to continue the conversation or the flow when for instance, it was some interruption and then you needed to like load back the user history, user session, so that you can continue, not start from the very beginning. But from the other point of view, it's very important that if you have like multi-user sessions at the same time, you do not mix up between them. It's also very important because, well, I believe everybody read the stories when, because of some wrong reg system or what's not, employees were able to read some sales letters, etc. That's not what we want to implement, right? So both are important. Do not overshare memory, but still keep all needed facts in the memory during the session. Everything can be covered by tests, so you can easily implement simulate kind of situation where you are now in the very middle of the session. Let's check whether all the traces from the previous steps are presented. Do I have all my headers? Do I have user history? Do I know where we stopped? So things like this. And also check whether you don't have any information from the other users. That's also very, I would say, important tests. Well, from memory, we can move to tool choice and routing correctness. And that's actually pretty interesting because there are quite a lot of tries, I would say, in the industry to check whether the route which our agent takes is optimal or not. And this is quite complex because it's easy to implement such kind of tests for pretty narrow workflows, but when it's complex and huge, this is actually a reason why do we move from the, let's say, workflow to agentic flow, right? So that we can allow our agents to be pretty creative into selecting the next steps and things like this. But what I mean here is it's very important to check at least parts of our workflow. Like, are we able to detect intent of the user correctly, especially the specific steps, the tool choice, the escalations, handoffs between different agents, and fallback paths. And here, actually, that's quite interesting because we cannot kind of label it for the whole user session, but for specific steps, we can. What we can do? We can say, OK, here's the first user's query, which this person made. We can do some intent detection and then check the quality of our systems detecting users' intent. We can say, OK, what is the first tool we choose to solve users' problem? And then we can also calculate something like precision of the tool choice or recall of the tool choice. And that's where I'm driving at. Just remember traditional classification task, right? Where we can label the correct inputs or correct user's intent. There is the user intent we detected with help of our model. So if we do have both, we can measure quality of our classification. Of course, it's not classification itself, but the approach to quality detection can be very similar. And let me bring an example here. I believe it will be much easier. Now I have tool choice example, but the idea is very similar. Just imagine that you expect that your agent should use specific tool for specific questions. Like if we're talking about the weather, we need to either call weather API if it's presented, or go for a web search and search for the weather, right? So for this kind of question, we definitely know that this tool is expected. Great, so we can construct the first row of our example query and known correct tool. Then let's go to the second. It can be something related to your customer base. So if your user asks about the order, you expect that your agent call the tool with the access to orders database, right? That's pretty straightforward. And then how we can add one more example to our database. And this is how we can create a data set with the expected tools. Then we can actually test our real agent with those queries and see whether these tools were actually called or not. So we have the ground truth, we have the actual output. You can calculate everything related to classification quality, multi-class in this case, precision, recall, F-score, and confusion metrics, which is great to understand where we mix up particularly. The same goes for user intent detection. Same goes for routing. For instance, you can say that, OK, when we are working with the booking and we get the questions, I need to get to London on Monday. OK, so this should be handoffed to the booking agent if you do have this agent in your subsystem. Great, so again, we can solve it as the classification problem and approach test with the same idea. Then how we evaluate that? I'm not going to tell you about confusion matrix and quality classification by labels, but just wanted to bring up those pictures. it's existed. We do have it independently as well. So if you need to debug what's going on, it's always good to have this classification quality by label, so that you say that, okay, I'm good for canceling booking, I'm good to booking confirmation, but I'm not great to updating booking information, right? So that's how we can debug that and see what sub-agents or what tools should be improved. Not like rebuild the whole agent entirely, but focus on things which needs to be improved. And I believe it's a really great approach to tackle the quality of the tool choice and routing logic from classification point of view. There are a lot of cooperation here. So nice. Let us move on to the next part, which are end-to-end tests. And I believe that's the biggest issue, actually, because there are a lot of user scenarios, and it's hard to make it very robust and non-flaky. We evidently also struggle with some flackier tests when some data sometimes not loading and etc. But we do need to have it. Just believe me, it saves a lot of time. So when it comes to end-to-end tests for agents, what to test for? I believe we always can start from the typical user journey, especially if you do have those scenarios which are very repetitive. It's always good to test for them. Also, there might be some business critical flows like reject booking or maybe do something in a very limited amount of time. This should be covered by the test as well. And also, there can be quite a lot of adversarial flows, which might be not that obvious, but I'm going to share some ideas of what types of queries can be also tested in terms of end-to-end testing. So let me start from the amount of what should be tested, and then I will quickly tell how to test this. We are going to discuss final output correctness, session level evaluations, and maybe something about the routing. So first of all, this part. When it comes to end-to-end testing, it's very easy to test it with help of humans, because you can just log into the system and do everything, like maybe call to your agent and try to book a hotel in New York tonight, right? Or you can try to build another agent, which is going to be doing pretty similar thing. So this agent is going to test your target agent and see whether it works or not. But of course, you can see kind of metaphor here, right? So this agent also should be tested and should work fine. So, well, it doesn't mean that it's impossible, but it's also like an investment. What is the test? Generally, you would need to come up with some configurations like what is the persona who is testing your system, what is the channel, maybe UI, maybe command line, what is the goal, and then scenario, at least briefly. And believe me, it does make sense even if you do human testing, because you would need to repeat and repeat and repeat the scenario. Maybe it will be done by different people, so it's important to have this configuration. And the golden rule here is what is written can be automated. Maybe not today, maybe later, but it can be automated. So that's an example of how your end-to-end test might look like. So tools required, the evaluation can be with help of LLM judge, maybe manually, but that's how it can be done. And well, what should be tested? You can consider creating a lot of different data sets, tackling different types of our queries. Edge cases, typical queries, critical business flows, and then quite a lot of things which are kind of important, and generally there are some let's say, business specialists or product specialists who really care about those things. What your chatbot says about your brand, how it compares you with your competitors, and things like this. So you can create a data set for every single type of such queries, like brand image, competitors, unintended contracts. Remember this case with Chevrolet sold by $1, right? So we can actually create data sets with this kind of queries where users tries to get some promises or maybe discounts or free products and test our agents for that. So quickly, how to evaluate? We can evaluate the final result always, whether it's correct or not. We can try to validate the correct journey, the road itself, but note, if you can draft it in the details, maybe you can move from the agentic API to the workflow. I mean, if you understand all the steps, maybe workflow is what you need, but that's just a side note. Well, we can test correct next steps, like if you know that after retrieval should be generation, just test for it. And of course, session level analysis. Like not trying to evaluate every single step, but say, hey, here is the whole session. Was the agent polite? Was the customer happy? This kind of things. And well, at the very beginning, because I know that we need to wrap up now, I just would like to cover up my presentation with few maybe practical ideas which might be pretty useful for agent testing. And I would say that, well, it's not always easy to implement everything, but it's always good to start from tracing and logging. At least you will collect those data, and you will have a chance to literally log into the user interface and read what's going on. It's already helpful. Of course, it's not like dashboarding and alerting, but you can read through it and understand what has happened, see where you spend most tokens, time, etc. That's important. Then it's always good to involve some domain experts, and that's exactly what even I myself faced in evidently. When I try to build something, technically it's good, it looks good enough for me. But then the domain expert comes and say, I don't want this to be like this. Please be more polite here, be more helpful here, add some pictures here. And this is why collaborations is very important. So it's always nice to allow your domain experts create some test cases and draft some expected answers. It really helps. And finally, do invest in data sets, because more data sets related to different issues you have, like maybe top 10 popular queries, competitors, something where users trying to get some financial advice, or maybe when users speak on different languages and see how your agents works, right? Something related to brand or maybe prompt extractions. It's always helpful because as soon as you can test against it before you deploy, you know better what is going to happen. So having more and more data sets actually pays off. Maybe you don't need to make it that long, so you spend a fortune for every single iteration of tests, but at least if you have enough, if it's diverse, if you have like 10 or 15 questions for every single topic, it's much, much better. So yeah, I think it's more or less the same what I wanted to say. Just like a final note, start with testing, start with something. Every single testing data set with 10 queries already much, much better than nothing. So that's my kind of final note. Create a simple data set and be sure about what you deploy to production. Thank you so much.